Okay, so the question is, well, first of all, the Jacobian is very easy to calculate. I mean, here's your relationships, u, v, and x and y, and you do the partial derivatives and you get this. And you actually, well, you get 2x. So if we integrate the Jacobian over region 1, which I've labeled here as region 1, we should get the area of region 2, shouldn't we? And I should probably put the absolute value signs here. I'm a little careless because our region involves only positive values of x. I didn't really need the absolute value signs, but want to remind ourselves. Okay, so the integral over region 1 is this. Now, that's a 3-region integral. You know, we'd have to divide the integral into this and this, or alternatively do it with respect to y. And that's straightforward, and I'm not going to bore you with that or aggravate myself with it. I'm going to do something more interesting and just, you know, interpret the Jacobian as a density. So this is nothing but essentially a mass integral, where the Jacobian 2x is your density. And if we sketch our region, we see that, we got the point 0, 0 here. We got the point 5, 6 here. So density equals 10 at the upper corner here. And density equals 0 down here at this corner, and it increases linearly as we move across. Okay, so if I want to kind of, I could do this by shading, but that would be great. So I'm going to draw a bunch of vertical lines here to indicate the density out here, and just a couple of vertical lines, maybe to indicate the density here. Then I'm going to space the vertical lines a little more closely. When I get out here, maybe it's like this. When I get out here, it's more like, okay, and then it gets dense, and the lines get closer together as we move out here, and they space further out as we go in this direction. Okay? Not a real good depiction, but to get the idea. Okay? And we could kind of say that, well, the density at the middle, you know, at the center of this thing, which is going to be at 2.53, density is about 6 here. Okay, density 0 here, 6 here, 10 here. We could just make the approximation that the average density is 6. Okay, now there's some subtleties to that. So, might be some subtleties. And let me repeat. Okay, delta of xy equals the Jacobian at that value of x and y. If your average density is 6, and the total mass is 6 times 16, equals 96. Now my area estimate was 70. Now if this thing actually takes up a little bit more of the region than I estimated, then 70 could easily become 96. So this is at least a plausibility argument. if you approximate the region from here to here by a rectangle of width 3 and altitude 4, it's got an area of 12, and the average value of the Jacobian, which changes linearly, is going to be 2x, 2 times. It is going to be 6, and you're going to have an integral of pretty close to 6 times 12. Yeah, 12. Remember my numbers, which is 72. Then you have the contributions here, so you can make approximations. And I don't want to do those integrals. Actually, temptation's getting me. I'll probably write them down here and then just do a quick flash of a video to show what the results are. I don't want to do that on screen. First place, I'll screw it up and have to fix it. And second place, you don't need to watch that.